So good evening, everybody, and welcome to this evening's Engineers Ireland GB presentation, which is on the route to zero emission buses at TfL. Tonight's event is also supported by the Roads and Transportation Society, the Mechanical and Manufacturing Division, and Energy, Environment and Climate Action Divisions within Engineers Ireland. So thank you very much for all your support in this. So tonight's speaker is Finn Coyle. Finn is a chartered mechanical engineer and has a background in diesel engine performance and emissions development. Finn works with Transport for London in the Engineering Directorate, where he is the head of engineering for buses. He is responsible for developing and implementing emissions reduction technologies for the TfL bus fleet. I'm now going to hand you over to Finn, and I'll join you at the end. Thank you very much.
Yeah, so my name is Finn Coyle. I've actually been in TfL 15 years now, so I've seen all of this transition from just our fitting of diesel particulate filters onto the buses to now our electric and hydrogen buses. So I'm going to talk about the London bus network and the emissions impact, especially CO2 that the fleet has, or zero emission bus fleet targets, or transition to getting the entire fleet zero emission, and the current interventions and trials that we're doing going forward. So, for those of you who don't know, the London bus network, it's a 24-hour, 7-day-a-week service. So, unlike a lot of other cities that have introduced electric vehicles where they're out for peak times and they can spend loads of times charging at night, we really have a 24/7 service. The only day all of those buses are parked up is Christmas Day. Otherwise, there's always buses on the road. And some of the old diesel buses could be out for 2 or 3 days with drivers switching over there. So it's quite a challenging duty cycle for us to switch over to zero emission. We do pre-COVID at least 6.5 million journeys per weekday on the bus network, and that's 50% more than the tube. So a lot more people use the bus network to get around than do the tube, even though most people associate transport in London with the tube network to an extent. 500 million kilometers approximately, slightly reduced now, operated kilometers annually. So it's a huge operated distance for the vehicles. The downside to that, it means statistically we will have crashes, fires, anything that's likely to go wrong, mechanical failures, door failures. Things do go wrong on the network simply because there's so many buses out there driving such a distance. 600 bus routes, almost 20,000 bus stops, and 8,700 buses. Slightly less than we had up to 9,000 before, but with Elizabeth Line coming in and better rail, national rail infrastructure in central London, so that number has reduced slightly. So when I first started in the job, TfL engineering didn't exist back then, but when I first started on vehicle emissions work in TfL, buses and underground were almost exactly equal for their CO2 impact, and both of them were around 650,000 tons per annum. Now you can see buses have got better, but not anywhere near as big a drop as the underground has, and that's the simple reason for that is years ago, back in 2009-10, we were reporting 400 grams per kilowatt hour, 400 grams of CO2 per kilowatt hour of electricity. And now that figure is 150. So there's dramatic reductions in the decarbonization of the electricity grid. But diesel has more or less stayed the same. You know, there's slightly more biofuel content in there, but the CO2 per litre of diesel burnt is more or less the same. We've introduced hybrid buses in that time, but there's clearly more work to do. The mayor has all sorts of net zero targets, etc. So there's a real drive to reduce that CO2 from the bus fleet. This is a chart that a colleague of mine pulled together that I find really useful for answering one of those questions I used to always get at conferences when I present before about us going to electric buses is people would say, oh, you'll use more CO2 in the production, making those vehicles and batteries, so it's a waste of time. You might save CO2 when you're driving, but you will create more CO2. The thing is, the buses last, for us at least, 14 years, and then they have a life after that. They don't go to the scrapyard after 14 years. The last 14 years in London, We will do one battery change during that time, which we've put into these figures. So yes, battery electric buses have more embodied CO2 because of the energy heavy manufacturing and sourcing of the precious metals for the batteries. But the operational life of that vehicle of 14 years in London, 60,000 kilometers a year, 14-year life. Some of the buses will do 1 million kilometers. There's such a saving per kilometer in CO2 that it makes really, really good sense for us. And even if the disposal is higher. And you can see it's the same for the diesel electric hybrids, not quite as good, but better. Hydrogen is something that we're keeping a close eye on. It is now, it's one of those things. It is more energy intensive to make hydrogen, but there's going to be much lower CO2 versions of hydrogen coming out soon. So those figures are based on the fuels that are currently available, but in future that may well be better. So what we've done so far, each of these would have been a sort of huge big presentation themselves, but probably for the Euro 6 retrofit and for the hybrids, I'll just do one sort of introduction slide and then focus on the zero emission. But the entire bus fleet was brought up to the Euro 6 emission standard for PM and NOx and for air quality reasons. Only hybrid buses have been purchased. I think the mayor officially said 2015, but in reality, since around 2012, all the double decks that we've been buying have been diesel electric hybrids. And then as of 2020, we've only been buying zero emission buses. So that's what we're doing now. In a way, we've been buying the easier zero emission buses first, the ones that do shorter routes, etc. We'll soon have to, every route in London will have to go zero emission. This target of when the entire fleet should be zero emission has changed a few times and it's likely to change again. The mayor has initially said 2037. Then the mayor brought that forward to 2034, which we're definitely on target to meet. But 2030 has always been spoken about if we get funding to do it. And in that case, we'll have to move a lot quicker and potentially do other things like retrofit existing vehicles into battery electric. So this is the SCR. Yeah, like I said, no, this would normally be an entire presentation itself, but I'll just quickly go over it. London had a real issue with NOx emissions, and it was the worst when the UK was in the EU. London was the worst in Europe in terms of nitrogen dioxide emissions in the centre. When we tested the first Euro 6 bus in 2014, we could see it was an order of magnitude better than the Euro 4 and 5 buses become before. They've been very strange emission standards over the years, but when we've had a real focus on NOx in London and PM as well. But PM was easier to control with a diesel particulate filter. But the NOx emissions with the Euro standards, we did not see the fall in real world emissions over our own test cycle that the legislation was requiring. So Euro 3, we were around 12 grams per kilometer NOx. Sorry, Euro 2, we're around 12 grams per kilometer NOx in a bus on average. Euro 3 came out supposed to be 40% better, jumped to 14 grams per kilometer NOx on our test cycle, so things got worse. Euro 4 came out, then got slightly better, but it was down to 10 grams per kilometer, so a little bit better than the Euro 2. And then Euro 5 came out and it was exactly that same 10 grams per kilometer again. So we were not seeing the engine legislative emissions improvements on our own real world test cycle. Then we tested Euro 6. The European emissions legislation for engines changed then, and rather than 10 grams per kilometer, we were below 1. So we had that order of magnitude improvement. Of course, the mayor's office saw this and we're thinking, right, everything needs to be Euro 6. And this was in 2016 that they were deciding we want the entire bus fleet to be Euro 6. We couldn't get rid of the buses in time to make the entire fleet Euro 6 emissions. But also our manufacturers wouldn't have been able to do that, build enough buses in time. And if you did really, really try hard to get them to build enough buses in time, it's kind of like this boomer bus thing. They could build a new production line and then they lose that and all that investment goes. So it's not a good thing to do to just ramp up the market. And then you'd flood the secondhand market with loads of vehicles that couldn't be sold. So we then focus on this retrofit scheme. We were thinking about there's obviously lots of new technology gone onto those vehicles. Why don't we try and get that and put it onto our older vehicles? And that was this selective catalytic reduction retrofit. We went a little bit beyond the Euro 6 standard in that we also limited the NO2 component of NOx, because NO2 emissions are what's measured on the roadside and they're a particular issue. And there is some criticism of vehicle emissions legislation that that's not separately limited, because you can produce as much as that as you like within the NOx limit, the NO2 ratio. And we also did a nitrous oxide limit, because nitrous oxide has a very high global warming potential, and that's not currently limited in emissions legislation. So we fitted 4,000 of those buses with this, with these selective catalytic reduction systems, and they were all in service by 2020. And we're monitoring those to make sure that they're given the in-use emissions reduction that they're doing. But with all diesel vehicles, when everything's brand new and tested on the test cell, and then it goes into service, there's a degradation there. And it's not just a degradation in the catalyst, it's potentially degradation in the injection systems and dosing up. And there's maintenance to be done on those systems, but it's very hard to keep them performing and as new condition all the time. So you might have seen in the press, there's been some criticism of SCR systems and real world emissions not dropping as fast as was modeled from the test data. And so that even though we're very happy with the improvements we've seen, it made us think the next step now is just to go down to zero, because there's a bit of variance in how well these do in the real world, especially when it's very cold weather or they're very, very congested traffic. They're not quite as good as they are on the test cell. Then on to hybrid buses. So this is even before my time. So in 2008, TfL, no, I joined in 2008. In 2006, under Ken Livingstone, TfL, with the Mayor's Office, had a fund for developing hybrid buses, and there was 56 of them trialed in London, 8 different models and types, and 2 of them then went into series production and were purchased. Hybrid buses back then were chosen as the most cost-effective way for TfL to reduce CO2 emissions from the fleet, because even though each individual vehicle was actually more expensive than alternatives such as natural gas, we didn't have to do any infrastructure changes in the garages. And I don't know if any of you have ever visited a bus garage, but a lot of them, Putney Bus Garage or somewhere where I've spent quite a lot of time, they're in a residential area covered over, and literally buses are parked nose to tail, and I struggle to squeeze down in between them when they're in there. So I hate if someone tells me a bus I need to see is like stuck in the middle of somewhere, because it's very difficult to get to. You don't have space for putting in natural gas refueling infrastructure there. Most natural gas refueling infrastructure takes gas at atmospheric pressure, has huge compressors and loads of space, and you know, compress it up 150 bar to go onto the vehicle. There's a few garages in industrial estates and out of London you can put that in, but most of them you couldn't. So a diesel bus back then would have been about 200,000, natural gas bus 220,000, a hybrid bus 300,000, but overall it was cheaper. And the only thing we needed to do is, all the technicians at the time were trained on diesel engine vehicles. They needed to get high voltage training as well for safety, because these vehicles operate at 600 volts, and you know, you have to be very careful when you're working on them. There's 3,900 of those in service now. Virtually every double deck. Certainly, if you're getting a double deck bus in central London, there'll definitely be a hybrid bus, and all the new route masters as well. So that was a successful rollout. No other city around nearly all major cities around the world trialed these, but they didn't have them successful. New York had them for a while, took them out of service. I think cities in Germany had them, took them out of service. One of the issues I think they didn't do is they didn't certify them to an approved test cycle to emissions reduction. So they purchased a hybrid off the likes of Mercedes and assumed it would be better for fuel consumption and CO2. Put it in service and it was hardly any different, even though they spent loads of extra money, because it wasn't verified and certified over a test cycle. So all of our manufacturers, and this new route masters made by Wrightbus, would have done a lot of development trying to optimize it for a London condition before they went into service. So it was a successful program for us. I keep having to remember to hit this mouse and then hit that. Right, there we go. I can do it now. So where we are now, we got 1,000, almost exactly 1,000 zero emission buses in the fleet, 20 of them hydrogen, the other 980 electric. 3,900 hybrids and 3,800 standard diesel buses. We never got the single deck buses going effectively on the hybrid driveline. But I got into a load of detail on it. With the double deck buses, we could downsize the engine from a 6.9 litre to a 4.5 litre when it was hybrid and had the electric drive. But the smallest commercially available industrial engine for a bus was around that 4 litre anyway, so we couldn't downsize any further. What I put in like a car type engine, and they just don't last. It only lasts a couple of years in service in a bus. So the awareness if they didn't have the reduction in CO2 that we would have liked. And also the single deck buses were much cheaper, but the hybrid was an additional 100 grand anyway, so the cost benefit wasn't as good. So we kept those as standard, the single decks as standard diesels. But that proportion, that, you know, all those diesel electric hybrids and diesel vehicles are now what we're transitioning to zero emission. And we've got another 700 zero emissions buses on order in the next 12 months. So this is the size of the challenge. I mentioned 8,700 buses. I think we started this before a lot of other cities, but when I go to Wright Bus in Ballymena, where a lot of our buses are made that end up in service in London, I see them all with, you know, TransLink and Dublin Bus, etc., going down, because a lot of people have started later. But the way our contracts work, routes, individual routes are up for tender, and then a bus operator bids to win that route. We award the route, and could be to the incumbent with existing vehicles that are refurbished, or with new vehicles. So then it could be, just say, for example, Route 12, certain passes Peckham to Oxford Street. Could go 40 of those could turn to electric buses, you know, in the next time, and then Route 63 will change, and so we go route by route, and other cities, you know, can just turn over lots and lots at one time. We think it's a good way to do it because we always have the latest. We're not stuck with outdated technology. The downside is you've got more older buses to get rid of. So it's going to take some time for us to get through all of those. Like I mentioned, we've got loads of the routes overnight. So we don't have, in China, they charge it, a lot of them charge at 40 kilowatts, and they can charge for, you know, 10 hours or something like that. And that's, you know, that's nice slow charge and not too hard on the grid. And they'll go out the next morning full, spend 8 to 10 hours out there, come back and then charge again. That's just not going to work in London. We need to do higher power charging. And do you want me to take questions at the end, Phil? I'm just thinking for the webinar. Yeah. I'll take it at the end. It's just because we're online as well. So yeah, loads of the garages to upgrade. 76 of them. They're already really tight for space. When you start putting in the chargers as well, loads of additional space is used. So that's an issue. The substation upgrades. Some areas where the garages have power capacity available, so it's not too expensive to upgrade to get the energy we need to charge the buses in those areas. Other places like Battersea, there's so much new construction, new homes, etc. there. If TfL or the bus operator also looks to take some of that power, I think there was a quote for 3 million to provide the power to charge a bus garage of 200 buses, and then hydrogen starts to look. Okay, so hydrogen, which is normally more expensive, it's like, okay, this might start making sense here. Some of them are. So they're getting the power available is a lot. That's the model, and I didn't do those figures. I think that's probably Jane and my team. 700 gigawatts hours per annum we predict energy consumed for that time. But this is a challenge with electrification of vehicles in general. And in Ireland, I read that for the first time, electric car sales have overtaken petrol car sales. So it's going to be, there's going to be an issue with this power. The grid needs to catch up everywhere, I think. McKinsey came into TfL a couple of years ago, just before COVID, 2018, 2019, doing a study on how TfL could cost effectively transition to a full zero emission fleet. They looked at everything, our route contracts, the types of buses, the distances they drove. And what they came away with from their cost modeling is, and at the time they said 85% of the routes, the cheapest, most cost efficient way is for what McKinsey were calling a big battery bus, or sometimes it's termed as, an overnight charging bus, just a standard electric bus, will do for the vast majority of the buses. For those that are high mileage, there's two competing sort of technologies: the hydrogen fuel cell buses, or the opportunity charged pantograph buses. Now, McKinsey's modelling showed that could be around 15%. Would be more beneficial to do those, because otherwise you would have to buy more buses and put more buses out in service to do that same distance otherwise. So if you did 20 buses could do 300 kilometers a day, and all of a sudden you would need 24 buses to do that 300 kilometers a day, because the battery electric bus doesn't have the right range, in which case you can start putting in pantographs in each end, or maybe do hydrogen. But I'll come on to it a bit later. The cost of that infrastructure, getting it in London, is much higher than they predicted, and much more difficult to do. And TfL probably aren't the cheapest for construction either, with all our standards, etc., to do that. And certainly I know from our current pantograph project, we have a lot of additional requirements on the suppliers that drives the cost up, for safety and for lots of other good reasons. So we probably won't. I think that 15% McKinsey quoted will be closer to 5%, but I'll come on to that a bit later. So here we are with our competing zero emission buses. The standard big battery bus, actually now cheaper than a hybrid bus, which is really surprising. And the reason for that is the leasing companies now think this is the future. And if we try and buy a new hybrid bus now, which we haven't done, but we sometimes get the prices for them, it would cost us more than buying a full electric bus, because they know the full electric bus will have another second life after the 7 years, or even have a second life going outside London with a new battery pack in it later. So that's very cost effective now, because you would think when we're transitioning to full zero emission, it's going to cost loads more, but in actual fact, the vehicles are now cheaper to lease. The big downside with these is the range is limited. Currently, that double deck bus you can see there, that's now about 500 kilowatt hours of battery, but the packaging constraints in it are quite tight. Even at the back of the bus, it's I would struggle sitting down in the back of that. It's just constrained in there. And also in winter, our range is limited. You can spend as much energy heating the bus as you do moving it around. So that's a real issue. We've had buses, not managing to service in the harsh periods during winter because of that. So definitely a downside to those. Charge time, you certainly don't, you need to take that into consideration. A lot of the buses are for 24 hours. You need to find a time where you can charge them. It's around, some of them down to 3 hours, some of them 5 hours, depends on the size of the battery, the voltage, and manufacturer of it. The range is in around 200 kilometers, but it is getting better. Then we have opportunity charging, and that's a mock-up of Crystal Palace. It is actually in there now. If anyone wanted to visit, that pantographs is in and installed. The beauty of these is you've got much smaller batteries in the bus, which has got two sort of benefits. One of them is there's less weight on the vehicle, so packaging is better, but you're also moving less mass around, so your energy consumption is lower. There isn't the environmental impact associated with loads of production of batteries either. And the range is kind of, you could leave them, if you have a pantograph charger at each stand, you could leave it out there for days if you want, so you're not range constrained. And in actual fact, we're going to have full air conditioning on those buses that are operating on that route. The downside of it is it's been quite difficult much more difficult than we predicted, getting power to the bus stations. A lot of those have complex lease arrangements, and for UK Power Network to put in a substation they want a 50-year lease, we might lease it off someone else who leases it off someone else. It ends up this convoluted thing, and it's quite difficult. The legal issues of installing infrastructure in some of these areas is definitely a downside to that infrastructure. There is places that are easier that I'll come on to a bit later. And then hydrogen. The beauty about this is the most similar to a diesel bus operation. It more or less fills up at the same time a diesel bus does, around 5 minutes. We think there was a lot of talk about the national government having a hydrogen economy, so we think there'll be funding available for that at some stage. The downside is quite a complex technology. All our technicians really need to be upskilled for that, and it's expensive. The maintenance facilities need to be, you need hydrogen detection equipment, lots of other safety systems installed there. Probably the real issue is the fuel supply. It's and everyone, chatted to colleagues in Transit Belfast about this as well. And the supply of hydrogen is not like buying diesel. Sometimes you can get it easy and sometimes it's difficult. And that probably will improve later, but it's definitely an issue for the vehicles at the moment. Another downside then is the energy loss. Most of the green hydrogen is made from electrolysis, so you're making hydrogen from electricity, but energy loss creating that hydrogen. Then you're transporting and compressing that hydrogen, storing and compressing, and pumping it into the bus, and all the way along there you have energy losses. So it's not as good as generating electricity and using that electricity to charge a battery. Even if you made that energy from a wind farm, would you be better sometimes generating electricity and power in a home than making hydrogen? So there's all of those debates, and there's some people that are very critical of hydrogen fuel vehicles. But like I said, for some, they could operate almost exactly like a diesel bus. So where it's very difficult or very expensive to put in the infrastructure, we can see need from it. And if there's national government support, and if there is hydrogen that, there's talk about blue hydrogen, decarbonization of natural gas, and carbon capture and storage, and lots of things. We're staying involved in the trial. We don't see it being rolled out much more yet, but you never know what will happen in the future. So the current interventions, I'll spend a little bit of time with it because we have a trial of, I mentioned if we're forced to bring this time forward where all our buses have to be zero emission, if we were told to bring that forward by 2030, we mightn't be able to get rid of the buses quick enough. So one option is to retrofit some of our existing hybrid buses to full electric. Talk a little bit more about the opportunity charging hydrogen, even though I've covered them a bit now. And then I'll talk about our new HVAC specification, because heat and cooling for these, we're going to have to be a lot cleverer on than how we've done it in the past. All right, so here's a schematic. Someone's put a V8 engine in there, and we definitely don't have a they're all 4 or 6 cylinder in the Combus fleet, but this is schematic of all our series hybrids. Basically, the engine drives a generator, which charges the battery, which drives the vehicle electrically. So the vast majority of the hybrids, including all the new Routemasters and the Alexander Dennis double deck buses you'll see, will be that kind of layout. We do have a few parallel hybrids that are different. So one thing you could do is take out that engine and generator, put in more battery storage, and you have a lot of the, the drive axle and powertrain all ready to go there. So the theory is that shouldn't be too difficult to switch over. It should be easier than a normal mechanically driven standard diesel bus. And here is a layout. This is a new layout of the new Routemaster below. I wonder if I move this. Yeah, I can see. So you can see underneath the stairs is the fuel tank, and there's some compressors there as well behind the driver. That's the ramp cassette there. This is the battery pack currently on the new Routemaster buses. I think it's about 50 kilowatt hours, so it'll do, it can do 10 kilometers easy enough in full electric mode. And that's the diesel engine, generator, and coolant pack there that's in the back, which is under the stairs of the new Routemaster bus. And then we have a company, Equipmake, who've taken that whole sort of engine and after treatment and coolant pack out of there and put in some batteries. These come from Nissan Leaf. Some more of them in front of the rear wheels, and some more batteries installed where the fuel tank would have been. And they can get 400 kilowatt hours of battery packs in there and get what they're predicting to be a 200 kilometer range. And we're keeping an eye on that to see if those figures end up being reality. So that's in service now on the trial, as a trial period. It's had to get a new front axle put on because it exceeded the weight limit of the previous vehicle type approval. For this to roll out much further, my preference would be, and I've already spoken to the Vehicle Certification Agency and the Driver and Vehicle Standards Agency, is a lot of companies are doing this, and they're doing it for cars as well. The danger is new vehicles have to go through a full type approval. You don't want someone to just not go through all that arduous procedure when they're doing a retrofit. So ideally, before this go much further, there should be some sort of national type approval scheme, just to make sure all the safety stuff's done, that people have looked at. Weight distribution is not affected, steering and braking systems are still fine, all that kind of thing. So that has the potential to be used, and probably used a lot outside London, where the buses don't have as, typically we have the buses for 14 years. Other cities might decide if they're going to invest all of that money, they'll want them for longer than that. And what happens is chassis start to corrode, and the repairs become more of an issue. In London, because the vehicles are operated 24/7, it becomes very difficult to run an old bus, so they tend to ship out of here and go somewhere else. But that could be for certain vehicle types in London, maybe ones that are in that 7-year age range, that could become a potential solution to get the whole vehicle, all the fleet electric by 2030. And I can see it being quite widely used outside of London as well. Then our opportunity charging I've mentioned. So this is low power in the garage, high power when you're out in the route. And the idea of it is the buses spend time at a stand anyhow. So they'll when they finish the route, they sit there on the stand and then start the route again, and they'll do that. You can charge at that stand, and we've done some analysis where if we charge at 450 kilowatts, all the bus routes would have enough time within the current stand time they have to take on enough energy to go back and run to the other charger. So that's one reason we're pushing for the very high rates, because that 450 kilowatts seems to be the sweet spot for us. So 450 kilowatts, if you charge at that, 6 minutes, so 1/10 of that, you get 45 kilowatt hours, and that's enough, a kilowatt hour per kilometer, to do 45 kilometers. But with heating and hills and all sorts of other things, quite often that isn't there, so you need to build some resilience into that. But that's the idea. This pantograph, this is a Spanish company, Irizar. We really forced them to switch over to this standard because they had the pantograph on the bus, like you'd have on a train going up to the infrastructure. We wanted the pantograph on the infrastructure because we wanted to be able to charge double decks as well. So this is now the upcharge standard, pantograph on the infrastructure, coming down to 2 rails in the bus. The bus pulls up there. I presume I'm doing fine for time and all that kind of thing. The bus pulls up there, and there is near field communication on the bus. So literally the driver just goes up, puts the vehicle into park, puts the handbrake on, doesn't have to do anything else. That pantograph will come down, hit the 2 rails at the top of the bus, and start charging. And there's a safe handshake between the infrastructure and the vehicle. And it's actually got 30 centimeters. You don't have to be perfect. You need to align a little bit, but that can move fore and aft and up and down, obviously. So unlike induction charging, you don't have to be perfectly aligned to get there. And there's the pantograph going in at Crystal Palace at the moment, but it's beyond that now, and it's more or less finished at Crystal Palace. And the route we've chosen is open in the Crystal Palace. That was 303 kilometers on average per day. So we would either have 20 buses and charge them either end with the pantograph charger, or have 24 buses charge in the garage and put out. So this kind of, if you think of buses, those buses are £450,000 each. And they're particularly, they're more expensive than maybe some of our Chinese BYDs, for example. But if you had to buy 4 extra buses, the infrastructure can start to pay for itself. So that was one reason we decided to put that route into pantograph. And then I think this is one of the last slides. This is the project we have in Perryville. So this is a dedicated refueling facility put in an existing bus garage. The trial we had before, we built a dedicated facility in Lee Interchange and had a completely separate maintenance facility in a huge exclusion zone, and a full separate hydrogen facility operating. Now we've integrated hydrogen bus servicing and refueling into an existing bus garage that also operates diesel and hybrid buses in there. Nearly all the maintenance of the hydrogen buses will happen inside in the shared maintenance facility. The only thing that'll be done outside is if we have to vent any hydrogen gas, that'll happen outside. This is now a fast refueling facility. So the bus and the refueling facility communicate with each other. If you want to fill hydrogen safely and you don't have that communication, you put it in at quite a low, relatively low pressure, because you don't want to exceed the pressure allowances of those fuel tanks. But if you've got loads of sensors on the vehicle and that's communicated to the refueling station, you can fill much quicker. And 10 minutes was a little bit long. And we prefer, because buses end up queuing up to get refilled. So we have this target now is 5 minutes. Also worth saying, this is like a generation 3 or 4 fuel cell compared to what we had before. Our single deck buses did about, we get the figures right, about 10 kilograms per 100 kilometers of hydrogen to 12 kilograms per 100 kilometers of hydrogen. That was a single deck bus in an easy route, RV1 in central London. These double deck buses are now down at 6.8 kilograms per 100 kilometers. So they're way more efficient. So, and the fuel cell has been not totally reliable since it's gone in. The main issues, we've had some of the issues with the communication between the bus and the infrastructure. And that turned out to be infrared sensors not being the tolerances and the build of the vehicles. That infrared sensor was in slightly different positions each time. So the communication was breaking down to the refueling station. They were filling slowly. So we've overcome that. That subframe you see there were some cracks appeared on that in the beginning. A whole new layout of vehicle, different. So we had to, they had to be taken off the road for a while and use stronger subframe put in. But overall, that's been reliable. Our main issue is getting the fuel. There's been a few days where we just simply haven't had enough hydrogen to run the vehicles, and we've had to send out single and double deck, diesel buses or diesel electric hybrid buses out there to replace them because there's not enough fuel. So if that's going to go roll out wider, we would definitely have to solve those issues. And then lastly, let's talk about the new HVAC spec, because old diesel engine buses, whether they're diesel electric hybrid or diesel engine, have that waste heat that comes off the engine that goes into the coolant package. It also circulates around the whole bus and keeps you nice and warm in the winter. So that was kind of nice, not quite free energy, but energy that would otherwise be wasted. With electric buses, we don't have that now. So lots of our vehicles, when it's very cold, have ended up using so much energy to sort of grind to a halt. I have to go back to the garage to get charged and more sent out to replace them. So we have to be a lot cleverer with our heating and cooling spec. So we've teamed up with University College London, who are doing lots of CFD analysis for us, and we're going to have a new heat pump only spec. We're not going to have any sort of resistive heating element on inefficient heaters in there. The heat pump will give us a nice coefficient of performance of 2 or 3, so you get more heat energy out than you put electrical energy in. We're going to on the left there, you can see the existing buses where the heat from above and also cool from above, which on the upper decks alone now. And if you look at that on the upper deck, kind of the heat just sort of circulates not too far away from the vents. So the industry all switched over to this years ago. But when you're trying to be very careful of how much energy you're using, you realize that's not an efficient way of heating the vehicle. So we're forcing all our manufacturers, and they've complained more about this than almost any other measure we've put in, because they're going to have to redesign the whole vehicle and how to duct the heating and cooling around it. We're going to heat from floor level and cool from above. And all the vehicles will have, it's kind of air conditioning. We won't call it air conditioning because it's not like if you go to Hong Kong or something, they've got a 3-axle bus and a full aircon on it. It's really powerful. It's an air conditioning system, but it's got a limited amount of power in it, basically. But it'll definitely improve. We're going to use that same energy to cool the bus in the summer as we do to heat it in the winter. There's no point in having been able to do, 250 kilometers in the summer and 200 kilometers in the winter because of the heating. People want to be cool as well. With climate change mitigation, the very hot days we're having, the overground now in London is full air conditioning, the Elizabeth line's full air conditioning. People aren't accepting that, extreme heats in the vehicles anymore. So that's coming in now for our next specification of vehicles. that we should improve that passenger comfort now as well. We'll have the trade-off, and we'll have the trade-off for some time. How much heating or cooling we put in versus how much range we get. Maybe in 10 years' time, we'll have so much extra energy in the batteries we can have a full aircon on the bus, but let's see. And that's it. So yeah, clear push from the mayor to introduce this. We have we've done the environmental analysis of the different technology types we're doing. Real clear political push from the mayor's office, and I expect, keep an eye out for announcements, but I expect something will be announced. Whether it'll be 2032 or 2030, I don't know, but I'd imagine we're going to be forced to do this a bit quicker. And we've got our, like we like to do, we're not just back in the one. We're keeping an eye on all of the. We're big enough bus operator that we can trial things and keep them going. Hydrogen might be expensive, but we can get funding from it from the European at the time. Pantograph, we subject to funding. We're trialing that too. We don't want to just. We're definitely going down this path because these technologies develop at different rates. For all we know, there'll be a step change in batteries that makes them a complete no-brainer, and the other things aren't needed, or the hydrogen economy completely change, and then all it makes sense for that. So we have these things trialed now, and I think it's easier for us to roll them out if those situations change. We're not putting all our eggs in one basket, basically. So that's it. Hope I didn't rabbit on too long. I'm happy to take questions.